These are notes 2.3. We're talking about correlation today. So I don't know if you ever noticed in Desmos when you made a line of best fit, when you use that y1 tilde mx1 plus b. You've done that back in Algebra 1 and Algebra 2. When you did that, it told you what the m is, it told you what the b was, and then it gave you an r and an r squared value, okay, at the bottom. I don't know if you ever noticed what those were, but this is called the correlation, okay? And a correlation basically tells us two things. If you think about our SOFA, what we've been talking about, it tells us the strength, okay? It gives us information about the strength, and it also gives us information about the association, okay? So how strong it is, and if it's positive or if it's a negative correlation, okay? So R, this number R, will give us that information, okay? So what is correlation? Okay, so a correlation, R, is going to always be somewhere between -1 and 1, okay? It has to be between these two numbers. If you see an R that's negative 1.21 or something, or 1.8 something, you know it's not the R, okay? R is always going to be between -1 and 1. Here's what it is. If I have numbers that are in a perfect line, my line of best fit would go like this, exactly through them. This would have an R of 1. Okay? Also, if they're perfectly straight line, my line of best fit goes exactly through them like that. My R would be a -1. Okay? So if it's really, really strong, it's 1 or -1. If I have points that are scattered all over the place, there's no real positive or negative, I have an R of 0. Okay? So there I can have, so anywhere in between those are the extremes. 1, -1, or 0. So if I have something that's like this, you can see it's a pretty good strong correlation in there. It might have an R of like 0.8. Okay? Also, if it has a negative slope to it, but still pretty close, maybe my R there is 0.9. Okay, oh, wrong. -0.9 because it's a negative slope. Okay, so that is interpreting R. So if we look at these here, if we look at these examples, okay, so very, very scattered. So this would be closer to R of 0. This one here has a little bit of negative tendency to it, but still very scattered. So think about on a number line. This would be somewhere, right around this area. Maybe negative. They have -0.3 here. Okay. This one has a positive slope to it, but it's very scattered. So it's on the positive end. Still pretty scattered, maybe around here. I'm guessing 0.4. Okay, they have 0.5. Okay, so there. This one here has a negative slope, so we're on the negative scale, and it's a little bit tighter, maybe 0.6, -0.7, okay, they have -0.7. This one here is a positive slope, getting even tighter yet, maybe 0.85, have 0.9, and then here, negative slope, even tighter, -0.99, okay? So in class, we're going to play a little game where you're going to have to guess those correlations. I'm going to put up a thing, and you're going to put it in the chat, and you're going to tell me what that is. Okay? So hopefully you understand what correlation is. So getting back to the SOFA part, it tells us how strong it is. Okay, by the 0.9, 0.8 would be fairly strong. -0.9, -0.8, still very strong. Moderate would be like 0.4, 0.5, 0.6. Weak would be like 0.2, 0.3, 0.4. Okay, somewhere down there. Association, we can also see whether it's positive or negative there. Okay. Next problem. Tell me if these are closer to 0, 1, or -1. Okay, so manatees are large, gentle, slow-moving creatures found off the coast of Florida. Many manatees are injured or killed by boats. Here's a scatter part showing that. So here we have the number of boats that are registered in Florida and the number of manatees killed. So there's a pretty strong correlation there that it's positive. So it'd be closer to, an R of 1. Okay. Number 2 here, the second one, B. This is a score on a test and where somebody sits in the class, in what row. Are they in row 1, row 2, etc.? And you can see it scattered over the place. And we wouldn't really expect that much of a relationship there. Where you sit in the class doesn't have which row you sit in doesn't necessarily have a deep impact on the score in your test. So we have a closer to 0 as our correlation there. Okay. So interpreting a correlation, you'll have to be asked to do this. So we have this. We have the time that it takes to run 40 yards. Okay. So the less time means the faster you are. And then the long jump, how far you could jump. So this was in inches. So this has an R of negative 0.83. So what does that tell us? Negative 0.83 means it's a fairly strong, okay, 0.83 is fairly strong. Negative means a negative correlation. So we would say that correlation says that a linear relationship between long is fairly strong and negative. Okay, so it's a strong negative correlation. Now, just because we have a high correlation does not mean that it's necessarily linear. So if I just give you this, and I say that R is 0.93, it doesn't tell us about the form of it, linear versus nonlinear. Because even if you look at this, we had looked at this in a previous video, the weights of a diamond versus the price of the diamond, not very linear, but the R to this, if you would draw the line of best fit, it would be fairly strong for the linear, but a non-linear would be a better idea there. So you cannot, to be able to tell the form of it, linear versus nonlinear, you really have to get a graph of it. We had talked about this before too. Just because there is a correlation, a strong correlation even, it doesn't mean that one causes the other. Okay, so here's some examples of that. Here's a graph of revenue from skiing in millions of dollars. So and this is the number of deaths from being tangled in bed sheets. Okay, that actually happens some. So we can see in different years, like this particular year, there were, I don't know, revenue was about $61,650, $50 million from skiing, and there were about 470 people that died from being tangled in their bed sheets. Okay, now that's a fairly strong correlation. It gives you 0.97, so it's a very strong correlation. Now, does that mean that if we spend more on skiing, more people are going to die from their bed sheets? No. Okay, those two things are not causing each other to happen. It's just that they're correlated. Here's another example of that. Okay, this is the amount of chocolate being eaten per person in different countries, and this is the number of people winning the Nobel Prize. Okay, so you can see that there's a fairly good correlation. Okay, I would 0.79. I'd call this moderate or moderately strong, in the middle there. So interpret this. So we can say it's positive and moderately strong. That's our interpretation. And then can we expect, if we eat more chocolate, that we can expect to have more Nobel winners? No. Okay. There's not a cause and effect between those two. Now, some things there are, but in this case, we have to kind of use judgment and logic. Chocolate consumption does not cause more people to win prizes. Okay, that's notes 2.3.